Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic structure of the atom and the periodic table. Today we are going to be looking at writing formulas, but unlike for the previous class when we were looking at just monoatomic ions, today we are going to combine monoatomic ions with radicals or polyatomic ions. So that is what we are going to be focusing on. So we will form compounds using monoatomic ions and radicals, and then you get an opportunity to practice on what you're going to learn. So the first thing that we will do is recap on what we talked about on radicals. So we said radicals are also polyatomic. The reason why they are polyatomic from the word poly meaning many, so there are many atoms. So they form one group of like atoms that have an overall charge. So they're also called radicals. So we have valencies and you can see the charges as well. So for this topic, we are going to be using the valencies. So it is important to remember the valencies of each and every polyatomic ions. They are not that many. We do have a larger list, but this is a list that we are going to be using a lot in high school. For in the case of just proceeding with chemistry, you will need to know other polyatomics as well. So we have the polyatomics that have a valency of 1, that is the ammonium ion, hydroxide ion, nitrate ion, hydrogen carbonate, and hydrogen sulfate. And you will notice there are some polyatomic ions that have a 4 like values at the end. We are going to talk about what you're going to do with these values. And then we have the ones that have a valency of 2. That is the carbonate, the sulfate, the sulfite. And you see the difference between the sulfate and the sulfite is the number of oxygen atoms. So for the sulfate, it has more oxygen atom, the sulfite, it has less. So we also discussed this in Form 1, so you can go back to the Form 1 video and check this out. And then we have only one radical in valency 3, but I've also said that we have other valencies. These are not the only ones. So the one in valency 3 is called phosphate, and you can see how it's written. So after getting this, now let's get into like how do we form these compounds from the polyatomic ions. So we are going to be combining the monoatomic ions in the 20 elements and these polyatomic ions. First, we list the cations and anions first. The cations always comes first. So let's take an example of magnesium sulfate. So when you look at magnesium sulfate, when you look at the ions of magnesium sulfate, we know the magnesium ion looks like this, it's a cation. And the sulfate, we said it is like this. Remember, you go back into that list that we have talked about. So if you look, magnesium is a cation, the sulfate ion is an anion. So after that, you list their valencies. Their valencies are derived from their charges. So when you look at this, it will become magnesium valency 2, and then sulfate becomes valency 2. Remember, we do not touch the main part of the polyatomic ions. The only thing that we are looking at is a charge, which becomes the valency. And then after you've done that, you place the parentheses on the polyatomic ion only. So the reason why we do this is because we do not want to interfere with any the structure of the polyatomic. It has to remain the way it is. The only thing that we interfere with is the charge. So if we were to repeat that one more time, we would put the sulfate in a bracket so that you can be able to see. We take it as a whole. So you can always do this, but with time also you're going to understand why we are using the bracket. So the next step is you crisscross the valencies. So in this case, so this is what we have. So we are going to take this valency and bring it here, and this 2, we bring it here. So we end up having something like this, magnesium with a 2, and then don't forget the bracket, then SO4, and then the 2 here. So you'll notice this 2 from the sulfate comes to magnesium, and this 2 valency from magnesium comes here. The next thing is the same rule that we talked about in the previous lesson. If they can be cancelled out, you cancel them out. So in our case, for example, magnesium 2 and then sulfate with a 2. So these ones can be cancelled out. We can cancel them out. And they are going to give us Mg into bracket SO4. So if you can cancel them out, cancel them out. The moment you see like this and there is no value outside the bracket, you do not have to put the bracket. So our answer becomes MgSO4. We do not put the bracket when we only have one polyatomic or the value here is 1. We never put brackets. So that becomes our answer. But there are some cases where cancelling out may not be required. We are going to see an example of that later on. So let's do some examples so that we can see what we are talking about. So we'll start with sodium nitrate. So we are starting with the compounds that have valencies that can cancel out, and then we go to the ones that cannot cancel out. So the symbol for sodium is Na, and the valency for sodium is 1. Nitrate, the symbol is NO3, and it has a charge of minus, so the valency is 1. So remember we said you put a bracket on it because you will need it. So you crisscross the valencies so that we don't get confused. So it becomes sodium 1 and nitrate 1. But we said you do not have to write this nitrate, you do not have to write this 1 1. So when it's 1 1, you just leave it. It's already showing us that it's 1 1. After that, since the number outside the bracket is 1, we do not need the bracket because already it tells us we can see it's only one polyatomic. So our answer becomes sodium nitrate. This becomes our answer. So let's look at another example, potassium hydroxide. So potassium is K, valency is 1. Hydroxide is written as OH, is also a polyatomic with a charge of minus, so the valency is 1. So you crisscross the valencies. So it becomes K into bracket OH. Remember it's 1 1, but we do not write the ones, so it becomes KOH. We said when the polyatomic is only one outside, there's a 1 outside the bracket, you don't have to put the bracket, so it becomes potassium hydroxide. We have magnesium carbonate. So symbol for magnesium is Mg, the valency is 2. Carbonate is CO3, valency is 2 because the charge is 2 minus. So remember we put the bracket and then we crisscross the valencies. So it becomes Mg2 and then bracket CO3 2. So these ones can cancel out, so we cancel them out. Becomes 1 and also this one 1. So we said we don't write 1, so Mg, and then we remove the bracket if there's only 1 outside the bracket, so it becomes CO3. So that is magnesium carbonate. So we look at calcium sulfate. So calcium valency is 2. Sulfate is written like this with a valency 2. So we said you put a bracket around sulfate and then you crisscross the charges. So it becomes calcium with a 2 and then bracket sulfate with a 2. So you can cancel out these 2's and it becomes 1 and this becomes 1. So since it's 1, we do not write 1, it becomes calcium. Then we remove the bracket since it's only 1, this becomes your answer. We look at calcium sulfide. So you can see there's a difference between the 8 and the 8. So once again, calcium valency is 2. And the sulfite is written SO3, which is a bit different from SO4. The valency is 2 because it has a charge of 2 minus. So remember we put the bracket. So we crisscross the valencies. So it becomes calcium with a 2, then bracket SO3 with a 2. Since this can be cancelled out, we cancel them out. and we do not write 1, so it becomes calcium. We remove the bracket because it's just 1, SO3. So that becomes calcium sulfite. So another one, we do aluminium sulfite. So aluminium phosphate. So aluminium valency is 3. Phosphate is PO4, and the Z valency is 3 because the charge is 3 minus. So you put this in bracket and then you crisscross the valencies to give us aluminium 3 and then phosphate with a 3. This one can cancel out, so we cancel it out to give us 1 and 1. So it becomes aluminium, then phosphate. That becomes our answer. So we also have a few examples with the transitional element. So remember iron 2, the 2 is valency for iron. So iron with a 2. Sulfate, we know it's SO4 and then 2. We put a bracket on the sulfate and then we crisscross the valencies. So it becomes iron, then a 2, then sulfate with a 2. And since we can cancel this out, it becomes iron, then SO4. We remove the bracket because only 1 is outside. And then last one using a transitional element, copper 1 nitrate. So from the statement, we see copper has a valency of 1. And then nitrate, we said it's that with a charge of minus, so the valence is 1. Remember, we said you put it in a bracket. So you crisscross the charges. It becomes copper 1 and nitrate 1. So we don't write 1, so it becomes copper nitrate. So next, we are going to look at the ones that do not cancel out. Or you can be able to cancel out but doesn't cancel out completely. So let's start with sodium sulfate. Sodium valency is 1. Sulfate, it's written like that, it's 8, so it has 4 oxygens, valency is 2. Remember what we said, you put it in a bracket and then you crisscross. So the valencies come here, this one comes here. So it becomes sodium 2 and then sulfate with a valency of 1. If it's a valency of 1, the valency of 1, this 1 comes outside the bracket, we don't put the bracket. So it becomes sodium with a 2 and then SO4. So this becomes our answer. So let's look at magnesium phosphate. So magnesium valency is 2. Phosphate valency is 3 from the previous. We have talked about this before. So you crisscross the valencies. So it becomes Mg3 into bracket PO4 2. You see these charges, you cannot, the valencies, you cannot cancel them out. So it has to remain this way. And you can see now for the first time, the number outside the bracket is not 1. So when it's not 1, we retain the bracket. So this becomes our final answer. Another one is potassium carbonate. So potassium, valence is 1. Carbonate, valence is 2. So as we said, you put this in bracket and then you crisscross the valences. So it becomes K2 into bracket CO3 and then 1. So this is 1 outside the bracket, so we don't need to put the bracket. So the answer becomes K2CO3, potassium carbonate. Then now we use transitional elements. So copper 2, that tells you the valence is 2. And then nitrate, valence is 1. We have done this before. You crisscross the valencies. So it becomes copper with a 1 and then into bracket nitrate with a 2. Since this is a 2 outside the bracket, we have to keep the bracket. So it becomes copper, we don't have to write this one, and then in bracket NO3 with a 2. So this one is the final answer. Then calcium hydroxide, calcium valency is 2, hydroxide valency is 1, it's a polyatomic. You crisscross the valencies, so it becomes calcium 1 and then hydroxide 2. So you can see these are 2 outside the bracket, so we have to keep the bracket. So it becomes calcium hydroxide. Another one is aluminium nitrate. So aluminium nitrate, aluminium is valency 3, then nitrate is valency 1. We put it in bracket and then we crisscross the valencies. So it becomes aluminium with a 1 and then bracket, then nitrate with a 3. Since the number outside the bracket is not 1, it's 3, we'll keep the bracket. But the 1 we don't have to put in aluminium. So it becomes aluminium nitrate. And finally, aluminium sulfate. So aluminium valence is 3, sulfate, the valence is 2. Remember to put the bracket on the polyatomic so that you don't mess with it. So we crisscross the charge, the valences. This becomes Al2, this 2 that came here. And then in brackets SO4, and then the 3 that was on aluminium. So you can see we are not going to tamper with anything. This is going to remain this way because aluminium is 2. We have to keep that. We are supposed to keep the bracket because it's not 1. So this becomes the final answer. So I hope you have seen the reason why we are using the bracket. It becomes easier when we get to such compounds as these ones. It's easier to see why the bracket is important. So you can see we are not interfering with the polyatomic ion, we are taking it as a whole. The only thing that we can use is the charge, which we convert to valency, but anything else in the polyatomic remains as it is. Do not touch any other value. So do not multiply this to become 12. It's supposed to remain as it is. So next we are going to look at the opposite. So apart from forming, you can be told to name compounds already that have been formed. So when we name this, it becomes sodium carbonate. The carbonate from the carbonate here. And then this becomes sodium hydroxide. This becomes beryllium sulfate. This one becomes lithium phosphate. This becomes magnesium nitrate. This becomes aluminium sulfate. This one becomes copper 2. Let's see how it is. So copper is a 2 here and carbonate. So this 2 is coming from the carbonate. So it means our copper had a valency of 1. So that's the reason why there's a 1 here. We put it in bracket to be 1. So this becomes copper 1 carbonate. There was a 1 here initially. And this becomes lead 4. You can see the 4, this 4 comes from lead, and then the 1 here comes from the nitrate. So it becomes lead 4 nitrate. So next, in this case, now counting the number of atoms in a given compound becomes very crucial because you're going to need this when we start balancing. So let's count the number of sodiums. So sodium, we have 2 atoms. Carbon, we have 1 atom from our 1 that is here. And oxygen, we have 3 atoms, as you can see. For sodium hydroxide, you can see sodium is 1 from the formula. Oxygen is also 1 and hydrogen is also 1. This one, magnesium, is going to be 1. You can see there's a 1 here. But when it comes now to the compounds in the brackets, like math, you have to open the bracket with this value. Remember, there is a 1 here that we do not write. So when we open the bracket, we multiply these 2 by 1. So our nitrogen becomes 2 because of it has opened the bracket. And then these 2 also multiplies with 3. So our oxygen becomes 6 atoms. It's important to understand this method. Aluminium sulfate, you can see aluminium, there are 2 atoms. Then these 3, it's used to open this bracket. Remember, sulfur is 1 atom, but now we do not write 1. So when these 3 opens the bracket, it multiplies by 1. So sulfur, we have 3 of them. And then this one multiplies by this 4. So oxygen, we have 12 atoms. So we continue. So beryllium, we have 2 atoms from what you can see. Sulfur, you can see it's 1, it's just 1. Oxygen is 4. Lithium, you can see the lithium, we have 3 atoms from what you can see. Phosphorus, you can see is 1 here, we have 1. Oxygen is 4, as you can see. Copper carbonate, this is copper 1 carbonate. So copper, we have 2 atoms, as you can see. Carbon is 1 because there's a 1 here, we do not write. Oxygen is 3. And finally, the last one, lead, we have 1. As you can see, there's a 1 here. And then this 4 is used to open the bracket. So nitrogen was 1 initially. This 4 will multiply by 1. So nitrogen will become 4 atoms. And then this 4 also will multiply by 2. So oxygen also becomes 8 atoms. So next, you're going to look at a few questions to conclude the session. So name the following chemical compounds. So you name this. This is aluminium nitrate. And then next we look at this. This is barium hydroxide. And then we have magnesium sulfate. This is sulfite, not 8, because you can see it's SO3. If it was 8, it would be SO4. Then we have copper sulfate now. And in this case, it's copper 2 sulfate because the valency on the copper was 2 and then sulfate was 2 and then they cancelled out. So it becomes copper 2 sulfate and it's 8 because you can see the sulfate. And then next question is we write down the formula of the compound. So potassium hydrogen sulfate, potassium valence is 1, hydrogen sulfate, valence is 1. Remember we put bracket, so it becomes potassium hydrogen sulfate. Both of them have the same valence. Magnesium phosphate, so magnesium valence is 2, phosphate valence is 3. So when you crisscross, it becomes magnesium with a 3. And then phosphate in bracket with a 2. We do not remove the bracket. Sodium hydrogen carbonate, sodium valence is 1, hydrogen carbonate, valence is also 1. So when you crisscross, it becomes sodium hydrogen carbonate. We do not need to put the bracket when it's just 1. And that brings us to the end of the session. See you in the next lesson.